participate in Chapter 2, Section 7, finding square roots and comparing real numbers. Square roots. Give us an example of a square root. Jimmy. He says square root of 4 equals 2. Thumbs up if you agree. Very good. Square root of 4 equals 2. And so what is a square root? What is it that you pulled a 2 out of there? So why did you pull a 2 out of there and say that the square root of 4 is 2? Braden. Because 2 times itself is 4. So inside that radical, I could have written 4 that way, right? 2 squared is 4, and the square root of 2 squared is 2. So squaring and taking the square root are inverse operations, aren't they? Very good. A square root is a number that may be squared to form a square number. 2 can be squared. 2 squared forms a square number. Isn't that interesting? A square number is a number that we can even show as a square. 1, 2, 3, 4. Oops, it's a slanted square. I'm kind of out of calibration. Let me try that again. 1, 2, 3, 4. All square numbers, perfect square numbers, could be diagrammed that way with a bunch of dots in a perfect square where base and height are the same. Okay? So, if b squared equals a, then b is the square root of a. It's a little bit of a tricky rule, isn't it? Okay, so let's take a look at a little model of a square root. So we have, there it is. We're familiar with this. We've talked about them and worked with them before. So who remembers what that little symbol is that is surrounding a? What do we call that? We know we have to say take the square root, but what is that called? So it's called a radical, right? Radical sign. So see, in math, we're very radical. And inside of the radical is this letter A. You know, we could have more than just a single term. We could have A plus B or something. The radical is a grouping symbol, like parentheses. You can have a lot of stuff inside of a radical. We'll find that this year. We will put a bunch of stuff in a radical. And we'll learn how to graph them and stuff, which is cool. But that whole thing inside of there, whatever it is, in this example it's called A, so that whole expression in there has a special name. Inside the radical we have the do you know what's inside of a division bar? You know those division symbols?
Yeah.
Like inside of divide, you know,
Dividend?
6 divided by something. What do we call that?
Dividend?
Dividend, right? So if this A is in a radical, we call it a radicand. It's kind of like dividend, but dividend is E-N-D, and this is radicand, A-N-D. Can you say it? Radicand?
Radicand.
Radicand. Okay? All right. So let's see it with an actual value. So square root of 16, go ahead and tell me, what is the value of the square root of 16? And Christina?
4.
She says 4. Is there any other possible square root of 16? 4 is true. Any other one? Emily?
2 squared.
Well, oh, okay, she's taking 2 squared, but that is 4. That is the same value, isn't it? Has anybody thought of something else you could square and get 16?
4.
You can square 4. 4 squared is 16. What else can you square to get 16? Anderson. Actually, there is another number. It's related to 4. Nico.
2 cubed.
Jonathan. -4. Look at that, -4.
Oh, yeah.
Isn't that interesting? You know that. Okay, so when you have the positive root, we call it, like the 4, we call that the principal root. Do you remember what we call the negative root? The negative one? If 4 is the principal root, if you're not a principal, you're a...
Student.
Okay, so the negative is the vice principal, right? I used to say it was a teacher, but no, it's just called the negative root, okay? It's not, we don't have a negative vice principal. We don't have a negative teacher. Okay, so isn't that funny? We have a principal root, and then we have the negative root. When you're given an expression like this, you're being asked to find which root. What do you think you're going to be asked to find here?
The negative.
The negative root. You see that? Because they give you the sign in front. So if you have a series of expressions and you're asked to find the root, and some of them have a negative in front, then they're telling you which root to find. So what is a negative root? What is a negative square root of 9? 3, 2, 1.
-3.
Good job, -3. How about this? Because they showed us a negative in number 1, number 2 has no negative, so which root are they asking for here?
Positive.
Or we call it the principal. The principal root. And so the principal root of 25 is 5. Third of 25 is 5. Sometimes they want you to find both roots. And in a whole series of questions like this, where some have a negative and some have plus or minus and some have none, then we know that number 2, they're asking for the principal root. That's a little tricky. If you were in an Iowa test and they just give you square root of 25, it might be like what I showed you here, square root of 16. They might want you to find both, right? So you have to carefully look at your choices in the answers. But here, in this whole series, we know that number 2, they were asking for the principal root. And this, number 3, they're asking for both. So your answer would be plus or minus
8.
Good. So you can write it that way, plus or minus 8. You could also write it as 8 and -8. Those are equivalent ways of saying the same thing, right? Okay. Good. Perfect squares. We just saw that 4 is a perfect square, and we were able to draw a little model of that. Can you draw a model of what is the next perfect square greater than 4? 2 squared is 4, so 3 squared is, can you draw that as a perfect square with dots? Go ahead and try that, and then you can check. Okay, you should end up with some little diagram like that. We have 3, base of 3, height of 3, or 3 rows of 3, right?
Yep.
3 squared is 3 times 3, not 3 times 2. Sometimes we make that mistake, but it's 9. And you see it forms a perfect square. Let's kind of list the first bunch of perfect squares that exist. So we can start with 1, 1 times 1 is 1, and then 2 times 2 is
4.
So 4 is a perfect square. 3 squared is
9.
4 squared is
16.
5 squared is
25.
So all of these perfect square numbers, 4, 9, 16, 25, we could make a little diagram like that, right? And find the base. 6 squared is
36.
7 squared. Oh, I skipped it. What did I get to? 10 squared, right? Once you get to 10 squared, I mean, we remember our times table, so 12 squared is 144. And then we kind of get lost, right? My wall has some other common squares all the way to 20. But what is 20 squared, really? 20 squared is?
400.
400. It's just 2 squared with 2 zeros, right? So what is 30 squared? 900. And 40 squared? 1600, and so on. That can help you estimating later, okay? We're going to approximate square roots to the nearest integer. Okay, approximating square roots to the nearest integer. What is an integer again? We need to remember that, right? An integer. Zach. Okay, a positive or negative number, but it must be a whole number, right? Whole number, no fractional pieces. Whole number or its opposite. So we're not going to get any decimal pieces or fractional pieces, okay? This is just an approximation of square roots, okay? So look at the square root of 32. Is 32 a perfect square? No, we didn't list it up above, and we know that 6 times 6 is 36. It's not that, right? So we're trying to find the closest integer to this. And it falls between two perfect squares, right? It falls between 36 and what's the other perfect square that it falls between?
25.
25. So we could write this down. It falls between these two. And the square root of 25 is?
5.
And the square root of 36 is?
6.
So it's going to be 5, well, actually, we're going to do that next. It falls between 5 and 6. So which of these two integers is it closer to?
6.
And how are you figuring that out? How do you know it's closer to 6? Michaela? The difference here is 4 and the difference here is 7. So it's closer to 36. So good. So that's how you choose it. If you are asked to approximate to the closest integer, you just choose which of these numbers it's closer to. Okay? So square root of 103. What are the two perfect squares it falls between? 103. Brayden. Okay? So you're saying the square root of 100, which is 10. That's a little less. And then 11 must be the next one, right? 121? And you're actually giving me your answer? Is that what you're... I think he's giving us the answer, and that is 103 is closer to 100, right? So the square root of 100 is 10. The closest integer for the square root of 103 is 10. Okay, try number 7 and then check it. Okay, what perfect square is 48 closest to? Alana? Because it's really close to 49, right? So she says it's close to 7. So what would your answer be here? What integer is this closest to? You can't just say 7 because there's something going on here that's a little different. Very good, negative 7. Okay, good. And then we have one other here, it's negative square root of 350. So we've located the perfect squares that this falls between, and the question is it closer to the square root of 361 or the square root of 324? And the answer is?
361.
Okay, so because of the negative in front, we're going to make this integer negative 19, right? We're going to walk through actually finding the square root by hand, like we did last year, right? And for the most part, you're only going to be asked to do what we were just doing, finding the closest integer. But every once in a while, you want to be able to find the closest square root to maybe the 10th place, okay? And who remembers the acronym we use to do that? FDAD, very good, FDAD. And so here are the steps that we've talked about, and we'll try it. I'm going to pause, take it down, and come back. Okay, so if we had a perfect square number, when we divide the value that's in the radical by the square root, we actually get a quotient that is an exact match for that between the divisor and the quotient. 7 times 7 is an exact match, isn't it? So when we try this with a number that is not a perfect square number, somebody give me a number that's not a perfect square.
51.
51, okay. Square root of 51. Let's try it. We're going to estimate, find the two perfect squares it falls between. Which two perfect square numbers does it fall between?
49.
49 and?
64.
64. Which is it closer to?
49.
It's closer to 49, which is, the square root of 49 is 7. So we're going to say 7 point something. And it's closer to 49 than it is to 64. So if it was halfway between, our estimate would be 7.5, but it's closer to 7. So give me your estimate. Rather than 7.5, it would be, right? 7.2. So there's our estimate. That's E. D is divide. Let's see if we have a match to the 10th place. 51 divided by 7.2. I'm going to pause the video, try that. So we have 7.2 going into 510, and we end up with 7.0. So this is where we get to the A in FDAD. These two are not a perfect match. So what does A stand for? Average. Take the average, which is 7.1. So we took the average, which was 7.1, and yes, we got a match. The best estimate is 7.1. Let's review one more time the difference between rational and irrational numbers. Rational numbers, just straight division, right? Square root of a non